So we are going to start chemical reactions. To understand chemical reactions, first of all what we need to know is what are physical changes and chemical changes. So we will start with physical changes. Physical changes. The types of changes in which the identity and constituent compounds after the reaction doesn't change. It all remains the same. Mass, identity or chemical compounds, everything just remains the same. So these type of changes are called physical changes. For example, we can take burning of a candle. In a burning of a candle, as you have seen, the wick of the candle starts burning. So when the wick burns, it produces ashes, that is black in color. So that ashes, that wick is something like in white in color. First of all, before burning, when we start to burn the candle, it turns like a black powder and it starts falling down. So that is example of chemical change that we will study after this. When the wax of the candle starts burning, then it melts. For example, this is the wick. The wax melts due to burning. Before burning, the wax is in solid state, but when it is affected by fire, it starts melting and converts into liquid form. After that, when it slowly starts coming down, it finally evaporates and forms gaseous state. If we collect this gas and allow it to cool it down, it will again form into liquid, and if we cool it further, it will turn into solid wax again, that will be wax again. So the wax is nothing but it changes from solid, on burning it changes to liquid, and then on further burning it changes to gas, it evaporates. 1 minute. It evaporates. Further cooling, if we cool it, it will again form into liquid, and on further cooling the liquid, it will again turn into solid. It will again turn into solid, that is wax. So this is what? This is just the change of state of matter of one single element compound that we know, that is liquid form. Liquid burns to form gaseous state, it evaporates, then gas again cools to form liquid, then liquid cools again to form solid or wax. So the identity of the substance is not changing, neither the composition of the substance is changing. Everything is same, just the state of matter changes from one matter to another matter. So the melting of wax in burning of a candle can be represented as a physical change. Another example. We have water. We have water. When we cool it, when we heat it, it will start forming vapors, or it will turn into steam. It will turn into steam. If using a condenser, if we cool the vapors, then wait a minute, then this liquid will again come into it. If we cool, when we cool the vapors, then this will form liquid, the H2O we will get back. If we further cool it down, or if we freeze it, it will form solid, that is ice. So if we heat water, it will form vapors or it will form steam. If we cool it down, we will gain back the liquid, initial liquid. If we cool it further, we will get the solid state, that is ice. So this is nothing but a change of state of matter. So this is called freezing actually. This is called freezing and this is called boiling. When on supplying heat, when we change the liquid state into gaseous state, then it is called boiling, and on further cooling, if we change the liquid state into solid state, this is called freezing. So the boiling or freezing of water is nothing but a physical change.
Okay.
Now we will move further to physical changes, chemical changes. Chemical changes. So chemical changes are the types of changes in which the identity, composition or color or state of matter changes to form a new compound, entirely different compound from the initial one that we started off from. These type of changes are called chemical changes. In chemical changes, new substances are formed whose properties are entirely different from the substance which we took at the start. So as we have seen in burning of candle, the wick which we burnt was initially in white color, it was in solid form before burning. When we burnt it, it formed ash, which is a black powder, and it will be in also solid state. The properties of the wick will be entirely different from the properties of ash. We can see that wick, if we pass air through it, it will not move easily, but ash will be blown away with air. Ash is much lighter, whereas wick is not much lighter. So we can see that the properties of wick and ash are entirely different, which can be accompanied as a chemical change. Another example, if we take sugar in a bowl and start heating it, at high temperatures, it will form a black substance. A black we can say paste like substance that is will be formed on the bowl. So the sugar which is solid state, the black substance which is paste or we can say semi molten solid state. So these the properties of solids and semi molten solids are entirely different from each other. So these type of changes are called chemical changes. Now we understood what are physical changes and chemical changes. So the question comes, what is a chemical reaction? Chemical reaction is nothing but a process of chemical change. Chemical changes are simply called chemical reactions. If we take magnesium plus oxygen, it will form magnesium oxide. Magnesium is a metal, oxygen is non-metal. So metal and non-metal, they have different compounds. They form an entirely different compound, that is magnesium oxide, which is a powdery state. We see that when we burn a ribbon of magnesium in air, then it forms a white, then it burns with a white dazzling light and forms a white powder of magnesium oxide, white powder. So this is a chemical change, as we can see. It will form a white powder of magnesium oxide. So chemical reactions are nothing but a process of chemical change. We can say that the process of chemical change is called chemical reaction, or the when two substances are reacted and they form an entirely different compound, or they form a new substance on heating or any other process, then it is called a chemical reaction. Now, this seems too much large to write. So how to make it shorter? We can make it shorter by writing their symbols. Magnesium we can write as Mg, oxygen as O2, and that magnesium oxide can be written as MgO. So this is called word equation, and when we write the similar equation in the form of symbols, this is called a chemical equation. Now, this is a chemical equation. You might be thinking, what is this 2 here? This 2. These are coefficients. This is done to balance the equations. So now we will see how to balance the equation. First of all, why to balance an equation? Before that also, if we remove this 2, then as you can see, the number of atoms on both sides are not equal. Oxygen here is 2, whereas here is just 1. So these type of equations in which the number of atoms on the left hand side are not equal to the number of atoms on the right hand side are called skeletal chemical equations or unbalanced chemical equations. So to balance it, we can see that here is 2 atoms of oxygen, here is only 1 atom of oxygen. So here is 2, here is 1, here the number of oxygen is more, here the number of oxygen is less, here is 2, here is 1, so we will put here 2. We will put the coefficient of 2, so we can see that 2 oxygen and 2 oxygen, it's balanced. But when we put 2 here, Mg gets unbalanced. Here is 1 Mg and here is 2 Mg. So to balance it, we will put another 2 here. Now we can see that 2 Mg, 2 Mg, 2O, O2. So now this equation, where the number of atoms on the left hand side is equal to the number of atoms on the right hand side, it is a balanced equation. These substances which are put on the left hand side of the arrow are called reactants. And these substances which are on the right hand side are called product. Reactants are generally the substances that undergo a chemical reaction, and product is the substance which is formed after a chemical reaction. So that is all that I wanted to tell.
Very good, very good, very good.